Hello, let's take a look at this definite integral with trigonometric functions. So if I want to find this integral, of course I will notice that in order to solve this I will have to use substitution. They do not give me a substitution, so I will have to choose a suitable substitution. So I'm going to either choose tan of x or secant squared of x. I will always choose the tan of x because if I say let u equals to tan of x, I'm going to find the derivative on both sides, du dx, and the derivative of tan of x is secant squared of x. If I'm going to make dx the subject, then it becomes 1 over secant squared of x du. So I can replace this dx with 1 over secant squared of x du. Whenever I am going to use substitution with definite integrals, I will also have to change my upper and my lower boundaries. So let's go and separate it here like this. So of course I can say if x is going to be pi over 3, so I take my upper boundary first, pi over 3. If x is pi over 3, what will my new u value be? So u of tan pi over 3 is equal to root of 3. So my new upper boundary for my integral will be root 3. Then my lower boundary for my integral, I'm going to say if x is pi over 4, which is 45, then u is equal to tan of pi over 4, and this is equal to 1. So my new lower boundary is going to be 1. Then secant squared of x multiplied with 1 over secant squared of x will be 1. So I am left with the integral of the cubic root of tan of x, but tan of x is equal to u du. So now if I want to go and integrate this, it will be maybe easier to rewrite it as u raised to the power of -1/3 du. If I find the definite integral of this, I will use square brackets, and this will be -1/3 plus 1 will be 2 over 3. I have to multiply with the reciprocal, and therefore close my bracket, upper boundary and lower boundary. So let's go and substitute in the values. So first I will do my upper boundary, so it will be 3 over 2 root 3 multiplied with, raised to the power of 2/3, and minus my lower boundary, so 3 over 2, u becomes 1 raised to the power of 2 over 3. Now the root of 3 is also the same as 3 to the power of a half, but 3 to the power of a half raised to the power of 2/3, so therefore it will be 3 to the power of a third. So 3 over 2, which is a 3 over 2 multiplied with 3 to the power of a third minus 3 over 2. And I can make it under one fraction, so 2, both have the same common denominator. 3 multiplied with 3 raised to the power of a third is the cubic root of 3 minus 3. This is my definite integral that I have been given here at the top.